Hi everyone, so in this video we are going to talk about images and how this section relates to the AQA GCSE specification. So for the exam you need to understand a few things such as what is a pixel, how an image is made up, and then you also need to be able to calculate the size of an image as well. So to start with, images are made up of these tiny little dots of colour, as you can see here, known as pixels. And one of the questions that pops up quite frequently is being able to define the term pixel. Now there's a few answers to this one you can choose from based on the mark scheme, but the one I always go with, pixel is the smallest addressable part or area of an image, okay? So that's or I always put a single dot of colour, which is normally also accepted. So a pixel is basically, an image is made up of these tiny little squares of colour known as a pixel, and they are the smallest addressable area or part of an image. So these little pixels, when you zoom into them, you can see them, but when you zoom out, they make up an image. So lots of different colours varied all over the place, okay? And the next thing you need to know about is the term colour depth. So colour depth is how many different pixels do you need to represent, how many different colours do you need to represent an image, okay? So if we go down to this one here, for example, let's take this one as an example. So we can count the number of colours on here. There is white, which is 1, black, which is 2, red, which is 3, and blue, which is 4. So in this case, we have 4 colours, okay? So there's 4 colours on this image. So I'll just write here. So there's 4 colours, okay? Now, the number of colours is separate to something called the colour depth, because the colour depth is how many actual pixels, how many different bits do you need to represent that many colours? So the way to represent it is 2 to the power, okay? So if we go back up here, I'll show you. So if I do 2 to the power of 1, okay, so 1 bit, I can represent 2 colours. Okay, actually I'm not going to write that, I'm just going to put 2, just because my mouse is making it look a bit sketchy. So 1 bit can represent 2 colours, and if you're thinking, well, how does that work? Well, if you imagine our binary table, so 1, 2, 4, and 8, let's do 4 bits, for example. Using 1 bit, I can represent 2 bits, either a 0 or I can represent a 1. So there's only 2 colours I can actually represent in 1 bit. Let's imagine I do 2 to the power of 2, so 2 bits, I can actually represent up to 4 different colours. And to show you again on this binary table here, I can now have 0, 0 using 2 bits, I can have 0, 1, I can have 1, 0, and I can have 1, 1. So each of these could be colour coded, so that could be white, black, red, and blue, for example. And as you can see, if you work your way up, so if we now do 2 to the power of 3, okay, that means I can represent up to 8 colours. Let's see, let's draw on there, let's try again. 8 colours, so now we've got kind of 0, 0, 0, we've got 0, 0, 1, and so on, okay? I'm not going to work out the combinations, but if you work them all out, you'll see there are 8 different combination of colours you can have, okay? So going back to my, down to here, this original question, if we've got 4 colours, that means we need 2 bits to represent 4 colours, okay? So in this example here, the colour depth equals 2, because 2 to the power of 2 is 4, so we need at least 2 bits to represent 4 colours, okay? It's important to remember as well that if I had, say, 5 colours, I would still need to use 3 bits. Even though it can represent up to 8 bits, we need that extra bit to represent at least 5 colours. So 2 to the power of 3 represents any values between 5 and 8. 2 to the power of 4 represents any values between 9 and 16, and so on, okay? So this question here, state the maximum number of bits or number of different colours that can be used if a bitmap image has a colour depth of 6 bits, okay? So going back to kind of what we talked about before, okay, we can work our way through. So we already know that 2 to the power of 3 gives us 8, 2 to the power of 4 gives us 16, 2 to the power of 5 gives us 32. I'll draw it on here. So 2 to the power of 5 means I can represent 32 different colours, and 2 to the power of 6 means I can represent 64 different colours, okay? So using 6 bits, I can represent 64 colours, okay? So the answer to this is 64, the maximum number of different colours I can represent, okay? So that's how you work out the colour depth. Now that's kind of one part then to these next kind of questions you will get in the exam, which is calculating the size of an image. So there's 2 ways you get these questions. One is it actually gives you an image, like so, which we'll come to in a minute. And the other one, it just states the details. So this one says, what is the minimum file size of an image, which is 800 by 1000 pixels that uses 20 different colors? So you normally get 1 mark for multiplying the width and height together. So we multiply the width and height. So 800 times by 1,000 gives us 800,000 there. Okay. Now we need to multiply that answer by the color depth. So there are 20 different colors. So remember, 2 to the power of 2 is 8. 2 to the power of 4 is 16. So I need 2 to the power of 5. I need 5 bits to represent 20 different colors. Okay, so I need 5 bits. So what we do is we multiply that by 5, which then gives us this value here. And then to turn it into bytes, we divide that answer by 8. And then to turn it into kilobytes, we divide that by 1,000. Okay, and then that gives us our answer, which is 500 kilobytes. Okay, so just to go through that method again, okay, if I kind of explain it in words. So stage 1 is multiply the width and the height of the image, which in this case is 800 by 1,000. Stage 2 then is to multiply the results by the color depth, which in this case is 5. Also to note as well, if you get the color depth wrong, so e.g. if you multiply it by 20, you would lose a mark there, but if your follow through marks were correct, so if you then did the next methods correct, then you would still get some marks. So now we've got it in bits, we need to turn it into bytes. So turn the results into bytes by dividing by 8. That's always the same. And then finally then, some questions will ask you to end it at bytes, but this one asks to take it to kilobytes. So in this example, we need to turn the results into kilobytes by dividing by 1,000. Okay. If it asks you to then turn it into megabytes, you can divide by 1,000 again, gigabytes, divide by 1,000 again, and so on. But generally speaking, you don't get those kind of questions. So our answer here is 500 kilobytes. So the kilobytes there. There we go. So 3 marks for that question. So let's look at a different style of question then. This one here actually gives us the kind of the pixel image. So in this case, a little bit of counting involved. So there are 1, 2, 3, 4, 5, 6, 7, 8 on this row here, and then 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 by 8 grid. So stage 1, multiply the width and the height. So 8 by 8 gives me 64. I then already know the color depth is 2 because I already worked that out because there's 4 colors, 1, 2, 3, and 4. So 4 colors, 2 bits. So multiply that by 2 for the color depth, which gives me 128. And then it asks me to represent what's it asking for? Why must at least 2 bits be used? Oh, sorry, it's not even asking that in the question. Let's suppose it's asking me to just represent it in bits, okay? So to turn it into bits, so bytes, I divide it by 8, which gives me 16, okay? And there we go. So that would be 16 bytes have been used for that image there, okay? So there we go. So that is how you understand what a pixel is, how to work out the color depth, and then how to calculate the size of an image.